The problems we're looking at right now, we want to help illustrate what is the domain, or can we find the domain of some of these rational expressions, rational equations. And so this will help us start to understand some of the properties that we're going to face when we look at these guys. So I wrote 5 different examples of some just various rational equations on the board, and we want to find out, can we determine the domain? Well, if you're looking at these, is there something that's coming to your mind as far as we need to be careful about? The thing that we need to do is that we want to be careful not to divide by 0. So we can't create an expression or equation that would force us to divide by 0. So each one of these is a fraction or a rational equation such that if I choose the right number, the denominator can become a 0, and I have to exclude that from the domain. For example, in this first one, the denominator is x plus 5. So what's the value of x that would make the denominator go to 0? X plus 5. I'll set it equal to 0, just so I can determine. So x equals negative 5. So my domain restriction would be all x such that x does not equal negative 5. That would be my domain. On the second one, same idea, x squared minus 4. What are the values that make the denominator 0? I'm going to factor this one out. Because once it's factored, then I can determine where the 0's at. And it determines it, or it says that there's a 0 at negative 2 and 1 at positive 2. So my domain is all x's such that x does not equal plus or minus 2. I can use every other number, but I have to be careful about those two. That's my restriction. X squared plus 1 is the denominator of the third example. So I'll set x squared plus 1 equal to 0. And it appears that there are no real numbers that make the denominator equal to 0. So I can choose any real number and I am fine. There's no way to make this denominator 0 with real numbers. The fourth example, the denominator is 3. There's no variables whatsoever. So the denominator, regardless which value of x I choose, the denominator will always be a 3. So therefore the domain here is all real numbers. And the last one, x squared minus 1 over x minus 1. The domain is all values except for x equals positive 1. One thing to note though is, some of you guys might have seen that, well, Willie, you could reduce this polynomial down. Well, if I factor the top one, you'll see that it does factor. It does factor in such a way that I can cancel out an x minus 1 and x minus 1, and I'm left with an x plus a 1. As a fair reduction or fair simplification of this problem, here there is no denominator. So I would have been unaware of any potential domain restrictions. But since this was a simplification or a reduction of this original problem, and this original problem did have a domain restriction, I have to be careful. These two guys are not the same right now. One has a domain restriction, the other one appears it does not. If I saw x plus 1 by itself and it did not come from a reduction or a simplification of another problem, then the domain here would have been all real numbers. But because it was something that was reduced, from here, this carries along with it a domain restriction. So this is true. All x, such as x does not equal 1, is true for this argument that we have.